Liquid-liquid extraction is another technique we use in the laboratory for isolating compounds from a mixture. It involves two phases, as the liquid-liquid extraction title is called, and one is usually an organic phase and one is an aqueous phase. So the goal is to move things between these two phases. The apparatus we use is a separatory funnel, as you see here. It is placed on an iron ring stand and rests on an iron ring, and then you want to have the nozzle placed underneath the side of an Erlenmeyer flask. Before you use a separatory funnel, you want to make sure that all the joints are properly sealed. That is, you want to add some water, make sure that your stopcock does not leak, right? Also, with water in there, you want to place your stopper in the top, invert it. The stopper should be lightly greased, and you want to make sure that nothing drips out the end. So you want to do this before you add any caustic acid or base, corrosive acid or base in it that might leak out. Okay, now what I want to do is illustrate handling of the separatory funnel and a liquid-liquid extraction using iodine with water and an organic solvent, which is going to be cyclohexane. I'm using the iodine and water to mimic what would happen during extraction, but in reality, when we get to the lab, you're going to have two clear, colorless phases for the most part, and not going to be able to see what's going on. You have to understand the solubilities involved and the principles of liquid-liquid extraction to know where everything is. To be sure nothing valuable gets thrown away, you should label all of your phases. So you can see here I have the aqueous phase labeled, and I'll have an organic phase that it's labeled. Again, don't throw anything away till your product is isolated. All right. I'm going to add some of the iodine in the water to the separatory funnel. The rule of thumb is that the phase you're extracting, in this case is the aqueous phase, is about 2/3 of the separatory funnel, and the solvent you're going to use should be about 1/3. Now, another really important piece of data you want to have before coming to lab and doing an extraction are the densities. We all know the density of water is approximately 1, and then the density of the organic phase, which is cyclohexane, I'm going to use is 0.774. So what does that mean? It means it's going to be less dense than water, and it should be the top phase of my extraction. So I'm going to add, this would be my extracting solvent, in about 1/3 of the volume. All right? You can see my stopcock is secure, nothing's leaking out. All right, now to perform the actual extraction where I want to transfer the iodine to the organic phase. So this is a definition of extraction, transfer of a solute from one phase to another. So I'm going to place the lightly greased stopcock on top, give it a tiny little twist to make sure it's sealed, and carefully lift the separatory funnel off the ring stand. You want to slowly do an inversion as the first step, and it's best to use your index finger. If you're right-handed, you use your right index finger. If you're left-handed, you use the left. And pointing the end away from you, gently tip it and open the stopcock to release any pressure that might develop with dissolution of the two phases, or as we'll see in the next video, any gas that might be formed. You close the stopcock, and now it's really important to mix the phases. So you give it a little shake, open the stopcock, shake it again, open the stopcock again, and I'm really going to mix the layers Give it a good shake. Vent it one more time before inverting it and swirling it and placing it gently back in the ring stand. Again, make sure you don't knock the stopcock as you're placing it back in the iron ring so that it opens and your liquids spill onto the bench top. I'm going to give some more vertical swirling to help separate the layers. All right, what you can observe in this very visual demonstration of extraction is that the iodine is soluble in the cyclohexane as well as in the water. So we have transfer to our organic phase. The distribution of the solute has to do with something called the distribution coefficient, the solubility in each of these phases. And as you'll read about in the Morg manual, the number of extractions you need to do is related to this distribution coefficient. What does not work is to do one massive extraction because you'll leave a lot of the solute in the aqueous layer. And you can perform a calculation that helps you understand this principle. All right, so we have two layers. We now want to separate them. First thing to do is to slowly open the stopcock and drain, in this case, the aqueous layer out through the bottom. If you had an organic phase that was more dense than water, for example, methylene chloride is more dense than water, so the methylene chloride would be the bottom phase. Slowly drain. And you especially want to slow down as the meniscus of the top layer reaches the neck of the separatory funnel, or the stem. All right? So bottom layer out through the bottom, and top layer is going to be poured out the top. Recognize that if I would drain this layer out through the stopcock, it would get contaminated with my aqueous phase. So I'm going to pour this extraction into my labeled Erlenmeyer. All right, because the iodine is colored, you can clearly see that I have not extracted all of the material into the organic phase. So to continue the extraction, I'm going to return the aqueous phase back to the separatory funnel. Make sure the stopcock is closed. Make sure your receiver is placed under the stem. And I'm going to use a second volume of the cyclohexanone for an extraction. So we will give you approximate amounts of extraction solvent to use, but it is approximate. You don't have to do precise measurements, just using a graduated cylinder and having approximately the right amount of solvent is fine. All right, so I'm going to tip it again, open the stopcock. I can see a little pressure there. Vent it again, shake it. And I've now performed my second extraction. And you can see by the purple color, my favorite color, that we've transferred more of the iodine to our second organic extraction. Though I'm not doing it here, you do want to wait till the layers separate. And so I would let it sit for 2 or 3 minutes or so till it's clear that both phases have gone to their appropriate positions. All right, so I'm going to drain again, aqueous out through the bottom. Be sure to watch the tip videos by Katie and Eric about draining the separatory funnel. Slow down when the meniscus gets to the top of the stopcock. All right, and again, think about where everything is in this during the extraction. So what I want to do is I have another extract of my solute that I desire. I'm going to transfer and combine it with the other organic phase. And now to finish the extraction, or this portion of the extraction, I would again return the aqueous phase to the separatory funnel, do one more extraction with the cyclohexane, and then I could be pretty much sure that I have removed all of the iodine solute from the aqueous phase into the organic phase.